Welcome to SRA 221. In this video, we will be discussing biometrics. In computer security, biometrics refers to authentication techniques that rely on measurable physical characteristics that can be automatically checked. There are several types of biometrics: fingerprint scanners, vein scanning, signature analysis, voice analysis, and DNA analysis. Biometrics are very commonly used in secure areas, or even in our day-to-day lives. If you have a newer smartphone, you probably use your fingerprint to unlock it. This is a form of biometrics. One of the main reasons biometrics are used is because they are universal. Each person should have a specific biometric trait. It is also unique because two people are sufficiently different in terms of the biometric characteristic. Biometrics are also collectible and must be obtainable in order to use them. Lastly, biometrics should be permanent, which are traits that remain invariable over time, allowing for repeatable measures. There are two categories of biometrics: psychological and behavioral. Psychological biometrics are also known as static biometrics. This is based on data derived from the measurement of a part of a person's anatomy. The second category, behavioral, are biometrics based on data derived from measurement of an action performed by a person and distinctively incorporating time as a metric, which is a measured action. We will now discuss some benefits of biometrics. The first benefit is that biometrics are linked to an event and are not just a password or a token. Additionally, they are convenient and can't be guessed, stolen, forgotten, or lost. Biometric authentication prevents impersonation and protects against identity theft and enhances privacy. Additionally, it can be integrated with other authentication mechanisms. Biometrics were first introduced in the 1970s and early 1980s. Some commercial use examples of biometrics include employee timekeeping and access to facilities. You might have seen a person in some movies going up to a door and putting their thumbprint on a finger recognition pad in a highly secure area. Additionally, law enforcement widely uses biometrics in investigations and forensic analysis, tying into border and immigration control as well. The acceptability of biometrics is commonly questioned by the private sector. A balance must be struck between how acceptable a security system is to users and its effectiveness in maintaining security. Many biometric systems that are highly reliable and effective are considered intrusive to many users. A biometric database would need to store a lot of user data, including fingerprint data, vein analysis, signature analysis, voice analysis, and DNA. As a result, many information security professionals, in an effort to avoid confrontation and possible user boycott of biometric controls, don't implement them in their systems. Compared to passwords and tokens, biometric authentication is both technically complex and expensive, and has yet to mature as a standard tool for user authentication to computer systems. This figure gives a rough indication of the relative cost and accuracy of the most common biometric measures. Facial characteristics. Define characteristics based on a relative location and shape of a key facial features, such as eyes, eyebrows, nose, lips, and chin shape. Fingerprints. The pattern of ridges and furrows on the surface of the fingertip, believed to be unique across the entire human population. Automated fingerprint systems extract a number of features to use as a surrogate for the full pattern. Hand geometry. Identify features of hand, for example, shape, lengths, and widths of fingers. Retinal pattern. Formed by veins beneath the retinal surface, is unique and therefore suitable for identification. It uses a digital image of the retinal pattern by projecting a low-intensity beam of visual or infrared light into the eye. Iris. Another unique physical characteristic is the detailed structure of the iris. Signature. Each individual has a unique style of handwriting, especially in signature. Voice. Patterns are more closely tied to physical and anatomical characteristics of the speaker, but still have a variation from sample to sample over time from the same speaker, complicating the biometric recognition task. In any biometric scheme, some physical characteristics of the individual is mapped into a digital representation. For each individual, a single digital representation, or template, is stored in the computer. When the user is to be authenticated, the system compares the stored template to the presented template. Given the complexities of physical characteristics, we cannot expect that there will be an exact match between the two templates. Rather, the system uses an algorithm to generate a matching score, typically a single number, that quantifies the similarity between the input and the stored template. Figure illustrates the dilemma posed to the system. If a single user is tested by the system numerous times, the matching scores will vary, with a probability density function typically forming a bell curve as shown. On average, any other individual should have a much lower matching score, but again will exhibit a bell-shaped probability density function. The difficulty is that the range of matching scores produced by two individuals, one genuine and one imposter, compared to a given reference template, are likely to overlap. In Figure 3.8, a threshold value is selected so that if the presented value is S is greater or equal to T, then a match is assumed, and for S is less than T, a mismatch is assumed. The shaded part to the right of T indicates a range of values for which a false match is possible, and the shaded part to the left indicates a range of values for which a false non-match is possible. The area of each shaded part represents the probability of a false match or non-match, respectively. By moving the threshold left or right, the probabilities can be altered, but note that a decrease in false match rate necessarily results in an increase in false non-match rate, and vice versa.